We have already looked at vertex form of a quadratic relation. So just to recap, the vertex form is given by y equals a times x minus h squared plus k, where the vertex is hk, and we can also tell the vertical stretch factor and direction of opening from the a value, the number in front of the bracket. Today we are going to look at the other two forms of quadratic relations. So as mentioned in the intro to quadratics, there are three different forms that you can have for an equation of a parabola. So we looked at vertex form. The first one we are looking at today is called standard form. So standard form is given by y equals ax squared plus bx plus c. Okay, so a, b, and c are all numbers. A and b are obviously coefficients. They are in front of the x squared and the x term respectively, and c is just a number on the end on its own. We looked at an example yesterday making a table of values with this, but we are going to talk about what the different numbers in this equation do, what effect they have in terms of transformations. So the number in front of the x squared term, or what we call the a value, there's a reason why this is why we use a as this variable and why we also used a in vertex form, because these numbers have the same effect in both forms of the equation. Okay, so your a value is going to tell you two things. It's going to tell you the direction of opening, and it's also going to tell you the vertical stretch factor. Okay, so the first thing it tells you, if a is positive, so bigger than 0, then your curve is going to open up. Okay, so it'll look like this. And if a is less than 0, so negative, that's going to tell us that the curve will open down. Okay, so it'll look like this. And similar to in vertex form as well, if a is anything other than 1, so if a is any number that's not 1, so if you see a number written there, right when a is 1, it'll just look like there's nothing in front of it. So if you have a fraction, or if you have any different whole number that's not 1, then there is a vertical stretch factor. So vertical stretch by a factor of the absolute value of a. Okay, and what that means, again, it just means it's the positive value of whatever a is. So if a is -6, let's say, the negative tells us that it's opening down, it's reflected over the x-axis, and the 6 is telling us that there's a vertical stretch by a factor of 6. Okay, so that's what a tells us. Again, we use the same letter as in vertex form because it tells us the same thing. And then we don't pay any attention to the b value. That doesn't tell us anything in standard form. It's there. It is what it is. But the number at the end of the equation, the c value, it says here the number being added, but this value can be negative as well. This tells you what the y-intercept is. Okay, so the y-intercept will be given by 0, c. Okay, so for example, if your equation is y equals negative 2x squared plus 7x minus 3, then the y-intercept would be 0, -3. Okay, so similar to when we have slope-intercept form of a line, that last number, the b value that's at the end, tells you the y-intercept. In this case, it's the c value, the number that's by itself at the end of the standard form equation. So that's the second form, and the third and final form of a quadratic relation is called factored form. And factored form looks like this: y equals a x minus r multiplied by x minus s. Okay, so it might not look like this would be a quadratic because you don't see the x squared term. However, if you were to expand these brackets by multiplying using the distributive property, which we will look at in the next video, there would be an x squared term. Okay, so y equals a multiplied by x minus r multiplied by x minus s. Now, the number in front of the brackets we see is also a, so it's likely safe to assume, if you've done so already, that it has the same effect as the a value in both of our other forms of the equation. So I'm just going to copy this information here. Okay, so similarly to in vertex form and standard form, if the a value is positive, that is telling us that the parabola is opening up. If the a value is negative, that's telling us that the parabola is opening down. And if the a value is any number other than 1, then there's a vertical stretch by a factor of the absolute value of a. Okay, so we use a in all three equations because it means the same thing in all three equations. Then when we look at the numbers inside of the brackets, we see there's two different letters here. There's r and there is s. So these numbers tell us what the x-intercepts are. Okay, so the x-intercepts are going to be given by r, 0, and s, 0. Okay, the key thing to note here is that the sign is going to flip. So similar to in vertex form, your x lies. So when you're reading that number out, if you had, for example, y equals 2, x minus 4, x plus 6, your x-intercepts would be positive 4, 0, and negative 6, 0. Okay, so you flip the sign. Anytime we're dealing with any number in the bracket that is with the x, remember that your x lies, you flip the sign. Okay, so that is the factored form of the equation. So you can see that all three forms tell us different things about the relation, the quadratic relation. All three forms will tell us the direction of opening and the vertical stretch factor, but we can tell the vertex from vertex form, the y-intercept from standard form, and the x-intercepts from factored form.